Hello. So today is the live stream advanced Arduino programming, kind of like the replacement for those who didn't attend. So we shall start straight away. So today we'll be only doing two sensors, which is the avoid sensor and the touch sensor. So from your sensor kit, the avoid sensor is this one, and the touch sensor is this one. So we will just use these two. So let's take it out. So we only use two sensors, which is the KY036 and KY032. So just a refresh. So when you need to find the data sheet for these components, you will need to use the names for such as for touch is KY036 to get the accurate data sheet. So in the data sheet, you will know the features such as the pin names, the pin out, which one should I connect, and also the code. So just a brief explanation about the touch sensor. So touch sensor have 4 leads, which is analog signal, ground, positive V, and digital signal. So you can see clearly from here. So this is the digital output, which is the digital signal. This is the analog signal, and then this is ground and positive V. So digital signal is to let us know whether the contact is detected. So it will go such as like the diagram of a analog and a digital. So digital signal is like this. So it was 0 is off, 1 is on, 0, 1, off, on, and off. So that is what the digital signal does. So it lets you know whether the contact is detected. So for analog signal is the measuring value of the sensor. So it will produce from 0 to 1023 to let you know around where when you touch the sensor. So there is a potentiometer for this sensor, which is this blue box. So you will need a flat screwdriver, which is something like this. So you need to use a very small one in order to turn the potentiometer. It's my small flat head screwdriver. So you will need to turn like this. So to know which side is the clockwise and anti-clockwise, you look at the words here. So the T and M, or look at this. So basically now this is facing you. So going clockwise will increase the sensitivity, while going anti-clockwise will reduce the sensitivity. So we will see how it works when you start to code for the touch sensor. Okay, the next sensor is avoid. So avoid sensor looks like this. There is a IR sensor in front, and there's 2 potentiometer, and there's 4 leads as well. However, we will only use 3 leads. The one labeled as EN is called null. We also call it as normally closed. So usually we don't connect to this one, we just leave it. We will just connect to out, which is the signal, positive V, and also ground. So positive V and ground will be connected to your maker UNO, which is the positive 5 volt, and ground at maker UNO. Signal for this we will connect to digital pin. Okay. So the signal for the avoid will be the output signal value from the sensor. So it will observe like that if there's a obstacle in front, then what will it do? So it's a on and off. So for the port potentiometer, you can adjust both, but each one is a different one. So if you can see 502, this is potentiometer 502. 502 means it is for reflectivity. Let me focus. Okay, so the 502 potentiometer is for reflectivity, while the 103 potentiometer is for sensitivity. So actually reflectivity we usually go all the way to clockwise. So it's the same as the just now our touch sensor. Clockwise means increased sensitivity, anti-clockwise means reduced sensitivity. So it works the same. So it will be like this way, and then clockwise will be increased sensitivity, while anti-clockwise will be reducing. So for this potentiometer, there is only like 180 degree. So it's from here all the way to here, and then end, no more already. Same goes for the POT 502. But for this one, you can turn any many rounds. There's no limit. So you just need to turn until you get the sensitivity that you want. Okay. So I think this is all about the sensors. So we shall start the connecting part. So connect the circuit according to the circuit diagram on the slides. So I will connect from here as well. So the first sensor we will use is touch. So you will need a breadboard to put your touch sensor, as well as your maker UNO, and wires. So this touch sensor I will be putting on different numbers because they are not supposed to connect to each other. Each lead will connect to different pins. So we'll connect on the breadboard on different numbers. So I'll connect from 11 to 14. So based on the label that is written on your touch sensor, connect to the correct pin. Okay, so I think this is clearer. So connect the positive and the ground first. So positive, I will use the red wire to your Maker UNO positive 5 volt. Then negative, I'll use a black wire to ground. So we shall move on to connecting the analog signal and the digital signal. So you can use any color that you have in your Maker UNO kit. So my digital signal, I will use an orange one to pin 6 based on the slide, then yellow for analog. So this is the overall circuit. So when this touch sensor is connected to 11, 12, 13, 14, it means whatever is labeled such as DO, which is connected to pin 11, the whole row will be connected to DO. Okay, so we can go to the software part. So we shall connect the Maker UNO to your laptop. Once you've connected it to your laptop, your touch sensor will have an LED light up. So your LED will be here. So now we will open the Arduino software. Arduino software. Software. Okay. So the first code that we are going to do is a example code. So go to File, Examples, Basic, Analog Read Serial. Okay. So Examples, Basics, Analog Read Serial. click on it and you will get a not new code, the example code in a different sketch. So I will delete this part. Oh no. Hang. So you can read these comments to understand the code. So for this analog read serial, we will be setting up using the serial monitor. So we need to set up the serial monitor by writing serial in and then 9600 bits per second for the data transmission. The void loop, which is the main code area, we will be having a variable here. So this declaration of integer sensor value. This sensor value is a variable, but it's known as a local variable. So this variable can only use under this function, which is void loop. But if you declare up here, which is like this, okay, this is a global variable. So the global variable can be used in both functions. So if I use sensor value at this board setup, I won't be able to upload it to my Maker UNO, as it will show the error, which it means that you did not declare this variable or this local variable or global variable on setup or on your sketch. So let's delete this. Okay. So analog read means we are reading the data from AO pin, which is this pin that you are connected from your touch sensor to your Maker UNO. Okay. And then we shall print the serial, the values, like data that we got it from the AO. So analog read AO is like your water, and then sensor value is like your bottle. So whatever is from the water, the analog read serial will be poured into your bottle. So it will continue print whatever the water is getting from the AO. Is it understandable? So basically you will have this water, which is the sensor value, and then you will have water, like any water, Pepsi, Sassy, Coke, anything, which is your analog read AO. So whatever is from the AO will be in the sensor value, which is like you are pouring water into your bottle. So now your bottle is full of the water, and then you are printing it out at the serial monitor. And then you will have 1 millisecond of delay. So we shall choose the correct port first, board and port. So board is Arduino UNO, and then port is check lah. So we will check if it's COM3, we'll use get port info. Okay, so mine is COM3. So for you all, you can find which one is the correct COM that you plug in, and then verify your code. It's taking very long. Jerkai is here. So Jerkai, can I ask, did you come for the live stream session last Saturday? You may write it in the chat. It's okay. Okay, so now we've done uploading. Then we will open the serial monitor. So now we will see the serial monitor is printing 1023, which is the maximum value of a analog pin that you can receive from an analog pin. So let's try to touch. So you can see from the video, when I touch, you can see the value changes. So you can try to see. Also, when I touch, the green light will actually light up. So if the green light is not light up, then you will need to adjust the sensitivity. Is everything okay? If there's no reply, I shall continue to the next code. Okay, there's no questions. So I will close this first. So we will type a code for the next one. So go to new, open a new sketch. So this time we are going to code using the digital signal only. So just now our code is just using an analog signal. So this time we will be using digital signal instead. So we will be like on off. So for the on off, we will do like this. So when it is touch, the serial monitor will print touch. If nobody touch it, it will print untouched. So when it's touched, the digital pin is actually high. So we'll be using if condition for this code. So first we will declare the pin name. Okay, so let's say now we want touch pin. So this is the global variable. So let's set up the serial monitor. Next, we will be doing almost the same as this code. However, we are using digital read. So we will put touch pin equals to digital read. So just now we connect to pin 6. We need to set the pin mode as well. So 6 as output. Okay. So set up your pin as well as serial monitor, and then read. So whatever is written from the produced or shown in the digital read produced from pin 6. It's produced from pin 6. It will be stored in touch pin, this whatever. So we will print. We no print. No need to print. So we will just make it as in if the digital pin from the pin 6 is high, which is the touch pin is high, then it will serial print touch. But if it's low, then it will print untouched. So it will put if condition. If touch pin goes to high, okay. So for if condition, you do not need to put a semicolon, but you will need to have the open bracket after you write the first line, which is this. So having the open bracket here, you can put in your statements of what will happen when this condition is fulfilled. So this will happen. If this happens, then I shall print touch. So what if this if condition is not fulfilled? Then we will have else. So if you can put else if, and then you will write your condition, which is touch pin low. Then it will serial print the untouched. So for the else if, actually we can also do it this way. It is the same because digital pin on is only producing 0 and 1. So there are only 2 numbers available. So if the first one is not fulfilled, it will jump to the second one. So if we have a lot of numbers, like a variety of numbers, like if this one is equals to 1, if this one is equals to 2, equals to t, what will happen? Then you will need to use else if, and then write your condition, and then put in your statement when that condition is fulfilled. So we will stick back to this. Oops. Never mind. We will type else if touch pin. So after writing this code, verify it, and then upload it to your. Oh, something is wrong. Expected declaration before token. Forget the open bracket. So let's verify again. So we'll see what will happen when we touch on the touch sensor after uploading. Okay, now we shall upload. Okay, so done uploading. We will open the serial monitor. So now the value is shown untouched. So because I'm not touching the touch sensor. So if I touch, So this is a bit tricky. You need to touch a certain way to make it able to read. Oh, it's not reading anything. Something is wrong. So my second LED is not light up. So probably some connection. So if it's not lighting up your way, so you can increase or decrease the sensitivity. Let me change the wire. Just now it's working fine. Drop something. Oops. Try the first code again. First code is fine. Second code, let's delete this and see. Oh, I think it should be input. Try input. It should be input. So because you are touching it, you are giving the Maker UNO a data saying that you are touching it. Okay, so let's try again. Yeah. So that's my mistake. I put it as output, so it should be an input. So when you touch it, yes. So you can see when I touch, there is green light, as well as the serial monitor is printing touch. Okay. So if this green light is not light up, maybe it's too. You need to increase the sensitivity. So let's say yours is too not that sensitive in a way. So probably see when you touch, there is no green light. So you have to turn clockwise. So you need to turn clockwise. Okay. Clockwise. Okay. So you see, once I turn to the correct how many times that you turn correct position of the pot, you can say, then when I touch, it will have the green light, but it's still not that yeah, it's okay for me. So when I touch, it will have touch word on the serial print, but it's not that stable. And then you will have the green LED. So I will increase more. Okay. So yeah, now the sensitivity is good enough. Is there any question on this sensor? Any question, you can write it in the chat and let me know so that I can help you with it. If there is no question, you can say no questions or anything. If there is no reply, I will continue another sensor in around 3 minutes. So we will continue the next sensor in 3:44. If you have any questions, please let me know by this time. So if you have no question, you can actually unplug the wires and we will continue to the next sensor. So you can unplug your Arduino UNO or the power off. Is it too bright? Since there's no question, so we shall continue to the next sensor, which is the avoid sensor. Okay, so let's unplug all this. Okay, same thing, we will still need all the wires as well as the avoid sensor. So the same way, I'm going to plug in 11 to 14, but 11 I will not connect to anything because it's a enable, or you can say normally closed pin. So this 11 I will not connect to any jumper wire. So you will need to connect to ground, positive, and out. So based on the void circuit diagram shown in the slide, connect them to your Maker UNO. So same thing, red, I will go for positive and then connect to the 5 volt on the Maker UNO. Then ground will be to ground on your Maker UNO. Okay. Did you connect correct? Okay. So it looks like this. Close up view. Okay. So these 2 pins are the ground and the positive. So connect them to 5 volt and ground. Okay. Then we will need one more pin, which is the signal. And where you want to put it. This signal will go to digital pin 7. They're fighting here. Okay. I need another. Okay. I'll use the orange as the signal. So digital pin 7. Okay. So now the circuit is done. It's a very simple circuit actually. So for both, the application is quite simple as well. Just need your imagination and creativity to create some things with all these sensors together. Okay. So once you finish connecting the circuit diagram, you can connect your micro USB to your Maker UNO and then to your laptop. So once it's connected, there'll be light on Maker UNO as well as your sensor, your void sensor. So if we go back to our code, you will be using the same example code. So you open your example, analog serial, analog read serial, and we'll try to verify and upload to your Maker UNO. So if you did not unplug your port, this cable from your laptop but just your USB, then you no need to choose the COM again, but you can check again just to make sure it is actually selecting the correct port as well as the board. So verify and then upload it to your we don't have analog this time, so this code cannot work. Oops, my mistake. So proceed to the code we code just now. Okay, this time seems we are just using the pin 7 and no analog, so analog read serial is useless for this sensor because we are not connecting anything to AO. So for here, we will just amend this code do some adjustment and we can use it for this avoid sensor. So instead of touch pin, we'll put avoid pin because this sensor is called avoid. Just a name for this. So since you change your variable name, you will need to change all the variable that you use in the code. Okay. Another thing is, since this time, based on the slides, we are connecting to pin 7. So we will need to change this pin mode, which we declare as pin 6, to pin 7. This one as well. So it's the same thing. We will be using serial monitor as well. And also we will using pin 7. And then we will have a digital read. So whatever you get from your pin 7, it will be stored in a void pin. However, at this if condition, for the avoid sensor, when it is high, it does not mean there is something in front. If it's high, it means there is no obstacles. So we show no obstacles. If the avoid pin is low, it means there is something in front of it. So when you are doing this way, like something, a wall, then it means it is detecting something. So the pin that it produced from the pin 7 is actually a low pin. So we have put obstacle. Okay. So after changing this, you can verify and upload it to your code. Okay, so done compiling, we shall upload. Okay, so before we test it out, so one thing to make sure is your 502 port. Okay, 502 port. Closer view. Okay, your 502 port. Okay, now I think your 502 port should looks like this. Now. Okay, so it should look something like this. So if we try, there is no second LED lighting up. So we will need to adjust the reflectivity first, then we will adjust the sensitivity. So for reflectivity, which is the port 502, we will need to adjust all the way to clockwise. So change here. So we will try from here first. So see when my hand is closed, you see the second LED is lighting up. Okay. So if you try to adjust the sensitivity, also can, or you feel this is alright, then we will open the serial monitor and see what is happening. Okay, so now it is. Okay, I will put it on the table this way so that you can know when there's. Okay. Oh, what's happening? Okay, so something is wrong. There's obstacles when there's no obstacle. if this is the case, we will need to adjust the sensitivity to clockwise. Okay, so mine is, I adjust until around this. Zoom in. It's focus and zoom in. So currently my both pods are this way. Both are almost at the end of the clockwise. So let's say I have something in front. So you can see the obstacles. If I take it away, there will be no obstacle. Okay, so let's say a A4 paper. Okay, let's not see. Okay. So now my A4 paper is the wall. Let's say the wall. Okay, the wall is here. Now my avoid sensor is coming. Oh! So when you reach around this distance, it will print obstacle on your serial monitor. So it means it detected something in front of it. So with this, actually you can do something, maybe use this on a car or some other object where it detects something in front of it. When, let's say, if it's low, if this pin is low, instead of printing obstacle, maybe you can do produce sound, show LED, or some other functions. So this is one of the functions where you can do also. So if there's obstacle, print obstacle. So this can be on a car, some robots car, or any other projects that you have in mind that require something like this. So it's almost the same as a ultrasonic sensor, but ultrasonic sensor you are able to put the distance, how far you want it to know the obstacle is in front of it. So let's say here is 5 cm. So when your ultrasonic sensor reaches 5 cm from the wall, it will print something. Yeah. So but for this avoid sensor, there is no adjustment on the values between the obstacle and your sensor, but it's quite sensitive. So you can use when it's low, what will happen. So same for the touch sensor. Let's say it can be maybe like your shopping mall. Currently now the door does not detect your motion, but detects it when you touch the push button. So this can be something like when someone touch it. So let's say when someone touch it, it becomes high. It will print a high. It will shows a high data or send a high data to your laptop. Then you can put in what will it do, or it will open the door. It will do this. It will do that. So these are a few applications for both of these sensors. So is there any questions? So this is the last sensor for today's live stream. So actually, when you are going through your Google Classroom, there is a challenge after the live stream material. So the challenge requires these two sensors as well as another LED sensor or a light sensor basically. So try to explore how to use the extra one more component or another sensor by looking or searching through the website with its data sheet. So from the data sheet, you will get all the information regarding that particular component. Then from there, try to connect it and code. So the requirements of the end result of this challenge is actually written in the Google Classroom, that assignment itself. So you can go and check it out and try it. So is there any questions? So today is 1 hour faster. Any question regarding these two sensors, or regarding the code, or regarding the connection itself?